So, yeah, I mentioned earlier in my introduction to the NFDI4Chem, and I outlined our aim to digitize the research workflows in chemistry, and the outstanding importance of the concept of the smart lab linking devices for capturing data, and also the ELNs for further processing the data. And the NFDI4Chem terminology service is another cornerstone on the way to machine actionable data, as it provides the information access to terminologies and ontologies needed for this inbuilt processes to semantically describe data. And several terminology services do exist with different coverage concerning disciplines and functionality, and also target groups. And I think most of them have already been mentioned today. We all know the ontology lookup service by EBI, the bioportal from MCBO, OntoB, bioregistry have been mentioned, and BARTOC, and so on. So there are many services out there. The first listed terminology service somehow provide the functionality of a repository. So we have APIs there and browsing and searching functionality for the users in the reference ontologies. And others are more registries like BARTOC, providing mainly metadata about vocabularies, terminologies, or ontologies. And I highlighted here two links, one for bioregistry, one for BARTOC, which provide a registry entry about registries. So there you can get the full comprehensive overview what is existing out there. And the entries at the end of the list are relevant for the communities in the NFDI and their consortia. We have seen by Juliana Zemlock P in the life science area, but we also have examples from biodiversity, the engineering sciences, and of course chemistry. And the NFDI4Chem terminology service is built upon the aforementioned OLS by EBI, and this allowed us to provide a running service early in the project to both human users and the NFDI4Chem services, which operate at different stages in the research workflow and which need to access ontologies on machine level to annotate data. And that's where we currently see a lot of potential use cases for the terminology service in this service to service applications. So terms from relevant ontologies can, for example, be used to semantically annotate chemical methods documented in the electronic lab notebooks, like in this screenshot shown here, the embedding of CHMO into the electronic lab notebook Chemotion. And the repositories of the NFDI4Chem Federation will also provide features to annotate data using terms from various ontologies in their respective upload processes. And you will hear more about that in detail in another talk tomorrow. And in the course of the project, we have gained quite some experience with the terminology service. And not all of them are of technical nature, but also concern content issues related to the ontologies and how these can be addressed with the terminology service. And one question that both users and developers of services asked for, and that's the most common one, is an overview of relevant ontologies for their own use case. So what is the best ontology? How can I recognize a comprehensive, well-maintained, long-term available ontology? And extensive metadata with license details, information about releases and versions, and publicly accessible repositories are a few of important criteria here. And also information about dissemination and application and projects or services. So how many have decided to reuse that specific ontology? Another issue is dealing with requirements for extensions or additions or changes in existing ontologies. While a number of ontologies are maintained on repositories such as GitHub, where issue trackers can be used. This is by no means the case for all of them. And further requirements addressed requests for new terms to be triggered directly in the user interfaces of the downstream services, such as the repositories or the electronic lab notebook, or alternatively, at least in the terminology service. And in general, what we have experienced is that the search for missing terms is often carried out across multiple ontologies. Where could the term already be defined? Where could it be best added? And so from our point of view, an overarching issue tracking or discussion threads of where to put it are interesting features of an terminology service. And in presenting metrics on the quality of ontology, where we were noticing how difficult it is to make consistent statements about versions and releases. So the idea was originally to make statements about the maintenance of an ontology from data on releases and versions. And this aspect can hopefully be improved in the future by more common use of tools like ODK for releasing ontologies. And last but not least, of course, especially for developers, a good documentation of the API is very helpful. All these insights indicate that there's a range of features of a terminology that can be much broader, especially if the service is embedded in a landscape like the NFDI. And not all features need to be offered directly in the terminology service, but it can act as a middle layer maybe. And the TIB as infrastructure institution considers itself as responsible for supporting and maintaining such a broader service, linking and embedding additional plugins. And so far we have identified three main features. The provisioning is obviously, or is the most obvious one. And while the publication and archiving of ontology is often achieved by public services like GitHub or GitLab, we see this as a future addition of a terminology service as well. We heard before that over the years, such services disappear, and then you need to move your archive or repository. So as a long-term oriented infrastructure institution, TIB might be a right partner for this purpose as well. Support for the curation process is a third feature, offering a platform to discuss across ontologies, simplify the process of filing issues for term requests or any other topic. And this could maybe be passed through the APIs to GitHub or other repositories, depending on the origin of the ontology. And for those actively involved in the maintenance of ontology, a direct initialization of tools like WebProtege out of the terminology service might be of interest as well. So regarding the further development of the terminology service here at TIB, we're currently in the process of separating the backend from the front end. And the new front end is built on React and interacts with the OLS backend API. And this allows us to provide both a centralized service called TIB General, which is across all discipline and communities, as well as services that are customized to specific needs of individual communities. And within NFDI, additional backend server can be operated to increase the reliability and stability as well. Consortia and communities may join forces here. So TIB and ZB made both use OLS and at the moment, and we are looking into potential synergies there as well. With that, we come to our next steps. So the release of the version 2 with the React front end is planned for the fourth quarter this year. And this will follow then developments to integrate the user management, so we can work on adding features for the ontology curation and community involvement and all the other aspects coming with that. And with regards to curation, we also look into providing metrics based on available metadata for an ontology to somehow express and evaluate the quality of an ontology. with this set, so I'm hoping to answer one or two questions.
Robot's been mentioned a few times today, but maybe not everyone is familiar with it. So Robot is a command line tool and a library for automating OWL ontology development tasks. And here's the link to the documentation webpage. Robot is, the name is Robot is an OBO tool, but Robot is not limited to OBO. It works on a lot of different ontologies, generally kind of anything in OWL format it should work with, although it does have conventions that are developed around OBO because OBO paid for it. And so here's kind of our stack. We have OWL API, Apache Jenna at the bottom, Robot building on top, and we have templating tools, we have workflow tools and version control tools like make and git. We have the ontology development kit, which we'll talk about next. And then we have tools like GitHub for like public repositories, public workflows, issue trackers. So Robot started in 2015. We've got almost 1,000 commits by 20 authors. We've got 20 releases. It's open source. It's written in Java 11. It's released on Maven Central. And yeah, it builds on the open source OWL and API and Apache libraries. There's two main parts to it. There's a command line interface with about 26 different commands that handles the AIs, the IO. And then the Robot core is code that you can pull from any different JVM language or even access with Python over the Py4j bridge. So Robot has a bunch of different commands. There's the OWL API kind of convenience functions for converting between formats, extracting, merging ontologies, mirroring them locally. And then there's reasoner convenience. So we're running the reasoner, we're getting explanations of axioms, relaxing and reducing our operations to mess with different logical expressivity that you want. We have different editing tools, especially like Robot template is something that we use a lot to convert spreadsheets into ontologies. And then we have remove filter operations, renames, diffs, repairs, all sorts of things. It's a Swiss Army knife. And then finally, we have Sparkle access as well. So we can do query, report, measure, expand as a new operation to take little snippets of Sparkle and expand them into additional axioms. But we use this stuff especially for our quality control processes. And in particular, like all the OBO projects now go into the OBO dashboard where an OBO Robot report is run to check a whole bunch of just different metadata requirements and look for common errors. And so we've really pushed our quality control by automating all these processes. And then Robot commands, they can be chained together into complex workflows. So here's something where we're like merging files, we're setting the version IRIs, we're making an adjustment using Sparkle, we're running the reasoner, relaxing, reducing, checking to see this all works. If it doesn't work, it'll fail. Running our report, if it doesn't work, it'll fail. And then converting into OBO format at the end. So we can run complex commands like this. When I started doing this stuff 10 years ago, you would do this in Protege and it would take you 2 days. So in the roadmap, we're working on a subset command for the, so this should be like the 1.10 release. And we have lots of documentation and help on board. And yeah, I feel like Robot has been a big win in the OBO community. The majority of projects, active projects, use Robot now. OBO has always been about standardizing on best practices and principles. And by standardizing, like having the best tool available, open source and free, we tell people, well, do it the easy way, use this free tool and it will do the right thing. And so we make the right thing the easiest thing. And so Robot has been a big win in this space, but there are still limitations to Robot. So in particular, OWL API struggles with large ontologies and it's a command line tool. Not everybody likes that kind of thing. And so I just wanted to gesture at some of the new tools that I've been working on to make this kind of functionality more accessible to more people, more accessible to less technical people often. And here we go. So LDTab is a tool for getting RDF and OWL into SQL databases, which means that we can scale much larger and we can load large ontologies in once and then reuse them many, many times and do a lot of the operations that we need to do just in SQL from any language that can speak SQL instead of just being limited to Java, a JVM platform. Wiring is for translating between different things, different formats, which we embed, especially like Manchester syntax with HTML links in RDFA format. I have an ontology-driven table validation tool, and then Droid is a web interface, so like a web server that can take your GitHub project with a makefile in it, and then make it accessible on the web so that people don't have to install that stuff. Droid doesn't actually know anything about ontologies, but Nanobot is specifically a web interface for ontology development that you can use locally or you can use inside a Droid container. And so I'll link to this in the document, but we have all these different small pieces of my consulting company, all these open source pieces. We're trying to put them together, into like a flock of tooling that's very flexible and adaptable to the kinds of things that you need to do. So Droid, for example, this is, you can go here. There's a whole bunch of different GitHub repositories that we have connected. You go to a particular repository and you can see all the different branches. You go to a particular branch and you have your version control stuff on the right, and then a curated workflow of operations that you can execute on the left based on your makefile, and then, command line output. And then we can jump to like the Nanobot tool, which is giving us a selection of the tables that we're using to define this particular ontology project, and then the upstream ontologies that we're importing from. So we can, for example, jump into the import table. We can see all our things that we're importing in table format, and then click a link and then jump to the tree representation of our ontology, and then whatever, browse around, jump back, view all the upstream ontologies like OB, for example, and browse through these things quickly. And so tables and trees next to each other in a web interface that connects them all together. This is the kind of vision for the next generation beyond robot. And so we're going to talk about ODK next, which is another important part of the OBO development stack. But remember that these are not limited to OBO projects. We try very hard to make them flexible for ontology development in general, and we make them all open source and freely available and as flexible as possible. So yeah, please feel free to email me with any questions about this stuff or follow up on either of those links. And I'll just keep it short. Thank you.
Thank you.
Yeah, I need to find the. Okay, sound should be free.
Hello everyone, I'm Nico and I'm going to give you a brief introduction
to
the
audio?
Ontology Development Kit ODK, a toolkit for continuous integration and fair release management for modular ontologies. When we build ontology, one of our great concerns is the definition and design of logical axioms in terms of many entities from different ontologies. So, for example, here we try to define the term of hypolysinemia in the human phenotype ontology in terms of a quality from Pato, decreased amount, an entity from Cabby, lysine, and an anatomical entity from Uberon, blood. And definitions like this is a relatively simple example here for illustration. These can be much more complex than just this. And a bunch of questions arise from the necessity of designing axioms like that. So, for example, first of all, how do I get terms from external ontologies to reuse them in the first place? I want to use the term of blood that is in Uberon. So how do I actually get the term of blood into my ontologies to be able to use them? Secondly, how do I make sure that whenever I make a change, I didn't break anything? Logical axioms can be quite complex, and it can be quite intimidating to having to make a change to one of them because you can't be sure, did this change that you've just performed maybe cause an unsatisfiable class, or did it create a weird cycle in my class hierarchy that caused unintended equivalent class axioms. So we want to be convinced that this change that we made is actually has the intended consequences. And lastly, how can we make sure after making all of these changes, after writing axioms like that, that all our users, our downstream users, can access the ontology in a standardized, fair manner? The ODK is a toolbox and an ontology lifecycle management system that solves these issues that I've just outlined above. Usually when we talk about the ODK, we separate it into kind of large branches. So the first aspect of the ODK is that it is a toolbox. A toolbox that is shipped as a Docker image, which contains all of the kind of tools that we want to use for our ontology-related workflows and processes, like Robot or the newly developed Ontology Access Kit, make general bash scripting, fast OBO as a toolkit for dealing with OBO ontologies, DOS-DP tools, many different reasoners, and many more. And the second aspect of ODK is that it is also a workflow system, so a system that allows us to specify executable workflows, such as refreshing an import or running a release in a standardized manner. So let's look at some examples. This here is this is here an example of the workflow of dependency management. So let's say we have added this term of blood into our ontologies. So we want to use this term of blood in our ontology. And now what do we do in order to get this from Uberon? So first of all, we want to have a repeatable workflow for that. So we want, if we import the term today, we want to be able to check maybe in half a year whether this term has changed, whether it has a different label, an updated definition, or even more, whether it has changed its classification. So we need some kind of repeatable workflow to refresh our import. Secondly, in line with that, we always want to be current with the axiomatization of our upstream sources. So that's maybe just another point to this above issue. And lastly, we want to make sure that when we are extracting modules, we can extract modules that are use case optimized, that allow us to instead of like using ad hoc term imports like copy paste techniques, or even worse, importing external ontologies as a whole, which will slow down people loading your ontology. Secondly, we have continuous integration testing. So usually what happens when ontology developers edit an ontology locally in our, let's say, world, is that they will make this change in a Git versioning system. They will then make a pull request, and then the CI system will run all of the different ODK checks, and it will fail if one of these tests will be validated. Will have not been validated. So which leads to a bunch of desirable things. First of all, there are no more broken ontologies on the main branch. Your developers and external contributors do not have fear to break stuff. And this all involves a rich set of checks, like from low-level things like OWL profile checking to more sophisticated testing suites like robot report, including many best practices from the OBO world, and also a customizable Sparkle-based unit testing framework, and of course all of the relevant logical checks. And a last example, the release pipeline. So we typically advocate a strict separation of editors files and release files in our ontologies. So here, again, we want to have a repeatable workflow that allows us to generate release artifacts from our editors file, following OBO best practices, which are not just applicable to OBO, but applicable to all ontologies. For example, releasing them in standard serialization, releasing them in different flavors and variants, human subsets, species subsets, and so on, and applying the best practices for ontology versioning as well. Obviously, we also want this to be fully configurable. So concretely now, we want to just to walk you through what happens actually. So when you're creating a new ODK ontology repository and you use the ODK to seed this ontology repository, it will create like a repository structure like this, where you have like a source directory with an ontology directory, and you can see in there the editors file that is going to be edited by your curators. You have a directory that has all the imports in it, and you have all of the different release files that live in the top level directory. These are all generated by this repository seeding techniques, and then from that point on updated by you executing these executable workflows. Then these Git repositories are typically managed on something like GitHub or GitLab, which we use for social workflows, and which also allow us to run continuous integration testing, as I have outlined before. So just a brief acknowledgement. So the majority of work on ODK in the last years was provided by the Phenomics First grant from NHGRI, but there are a lot of contributions from the community and in particular the core team. If you're interested in learning more, please find the paper here on arXiv, which is also under submission and database and should be published shortly. There are more than 70 currently documented uses of ODK. Thank you very much.